This problem has two steps in the heating curve. First, we need to heat the ice from below its transition temperature to its transition temperature of 0 degrees C. We have to heat this ice before we can melt it. The heat involved is the heat times the mass times a specific heat capacity, and we need to be careful such that we use the specific heat capacity for solid water, not liquid water. The second step is we're going to melt the ice from 0 degrees C to liquid water at 0 degrees C. It's a phase change. So the heat is the mass times the enthalpy of fusion. All right, here's the setup. We have our mass times our specific heat capacity, and again we use a specific heat capacity of solid water or ice, and our delta T that we've calculated down here. Here's our energy for our phase change. Mass times our heat of fusion, both expressed in joules per gram. So both of these values are going to be added together in order to get our final amount of heat, because both processes are required in this transition from ice at minus 25 to liquid water at 0 degrees C. Let's look at our units. We see units of grams cancel, degrees C cancel, so joules survives here and here. Now, if we're looking at sig figs, we see that delta T here limits us to 2 sig figs. So this number is good to the tens place. On the second calculation, we have 3 sig figs, so we're also limited to the tens place. So when we add these two values together, we see we are only good to the tens place. To write the number of our answer correctly with the appropriate number of sig figs, we're going to have to use scientific notation.